Okay, here let's graph a couple of, actually a few equations. I'm purposely going to do one called a hyperbola first, because that was the request for this particular video, but then I'll show you how it's related to another hyperbola, and then also the corresponding ellipse that all kind of have a similar graph here. Normally it'd be more reasonable to go with the ellipse first, but the request was for a hyperbola, so we'll do a hyperbola graph. So here we see a hyperbola that has a shift right 3, y plus 1 would be shift down 1. This is the generic form or the standard form of a hyperbola. So as I go in here and start to make a plane, and on this plane I'm going to go to the right 3 on the x-axis, 1, 2, 3. Along the y-axis I'll go down 1. So there are the coordinates 3, negative 1. That's the center of this hyperbola. And then in order to figure out how much to go along each axis, I'll take the square root, or the size change, a factor here essentially of square root of 25 is 5. So along the x-axis, because it's under the x, I'll move 5. 1, 2, 3, 4, 5. This is at 8, because this one was at 3. And then 1, 2, 3, 4, 5 will put me at negative 2, 1. And then along the y-axis, again, I'll take a square root. The square root of 4 is 2, so I'll go up 2. And then I'll go down 2. And that'll put me at negative 3. And what this does for us is this effectively draws a perfect little rectangle. Right? Move that x move around that center, getting that x movement and that y movement. That rectangle provides two beautiful diagonals. So here's the diagonals of that rectangle. And then the hyperbola is due to the fact that it's a subtraction, and the fact that the x is first, the x is positive, means it opens along the x-axis. And so here's where we're going to get this gorgeous hyperbola shape. You could also find this just by plotting points. Remember, that's kind of the goofiest way to graph, but it works every time. And this creates the hyperbola. But the main reason I want to introduce it in this way with the transformations and the box is because now when I turn on the next layer, here are two related graphs. In this case, in the green case, we're trying to draw the same shift, right, 3 down 1, but we've reversed the order of what is positive and what is negative. So if you followed the same logic I did last time, the box would be the same, the diagonals would be the same, but due to the y being the positive factor this time because of the switch, you'd now open vertically. So the hyperbola would still have the same box and diagonals, but it would move open this way. So you get the hyperbola shape. And then finally, if you were fortunate enough to get the blue shape, which is why we usually like to do this one first, but for the purpose of this video I did it last, same shift, right 3, down 1, same shifts, same size changes, but with the plus, this is now effectively a squashed circle, right? Instead of having a radius, it now has different compressions along the two different axes, or stretches in this case. And so in this case, same box, don't care about the diagonals, but now in blue, that's where we get this elliptical shape. So this same equation with a couple of different effects give you essentially 3 different shapes depending upon whether it's a plus or a minus, and if it is a minus, which one is going in the correct or which one is the first direction.